All right, ladies and gentlemen, we're talking about 7-6 today, exponential growth and exponential decay problems using those exponential functions. Here's a couple warm-up problems for you to work on while you're waiting for me to adjust the screen. So we will check these things over again tomorrow when you get into the room. All right, so let's get rocking right away here. We're going to start off with new vocabulary words. Our new vocabulary words that we're talking about obviously are going to be the things that we have not yet talked about. So we have things called exponential growth, compound interest, and exponential decay. Now, growth and decay are very similar types of problems. One is increasing, one is decreasing by a certain percentage over a period of time. And then compound interest is a special type of an application for exponential growth. So we'll be dealing with both of those things. Now the first formula that you are going to see is our exponential growth formula, where A is the initial amount, R is the rate of change expressed as a decimal. So you're changing the percent to a decimal. And then T is time in years for us. All right, so here's our very first problem. Our directions are to write an equation to represent the population of Flat Creek since 2008. And then part B, which is to, according to the equation, what will the population of Flat Creek be in the year of 2018? So the problem says that in 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. So when we plug those things into our formula, remember our formula was y is equal to a times a 1 plus whatever the rate is to the power of t. So we're going to plug in a is 280,000. Our percent we're going to change to a decimal. That will be the r. And then t is the number of years since 2008. So our equation will say y is equal to 280,000 times a 1 plus this rate. So the decimal point moves over 2 times to the left. So I'm going to do 1.0085 because 0.85% turns into 0.0085 plus that 1 in front, and then to the power of t. And our job will be then to be using t as our input to figure out what y is. And y will be then, of course, the population. So part B is to plug in this 2018 the correct way, because it's the t is the number of years since 2008. So we're going to subtract those two and get a 10. So we're going to plug in a 10 for this to calculate our official number. So you would type into your calculator 280,000 times a 1.0085 to the 10th power. So I will do that exact thing here. 280,000, 1, 2, 3, parenthesis 1.0085 parenthesis to the 10th power, and my calculator says that the population will be y is equal to 304,731.29. Now we can't have 0.29 people, so we're going to get rid of that part of it, and we're going to have 304,731 people with an inflation of 0.85 per year, which kind of makes sense in 10 years that you would inflate that much. I mean, 1% is going to be quite a few people itself. All right, so here's your first chance to prove that you know how to do these things. Plug the same types of just regular exponential growth in. That's your multiple choice question to fill out on the Google form question. All right, and here's our next one. This is compound interest. The compound interest formula says that A, which is the current amount of money, is equal to P times parentheses 1 plus the rate divided by N. N is the number of times it's compounded in a year, and then raised to the N times T. T is the time in years again. P was the principal or the initial amount. So that information you're going to need to have written down someplace handy for you, because that is a formula that we're going to use for our next problem. So we have Jing Mei, and she's got a nice set of grandparents. They invested $1,000 into her. So again, we're going to use that formula. $1,000 is going to be our P, so 1,000 goes in for the P. And then that's going to be times a 1 plus the rate divided by the number of times it's compounded. The rate is 7%, which is 0.00, oopsies, too many zeros, 0.07, 0.07 because we moved it 2 times, divided by n. N is the number of times it's compounded in 1 year. And since it says the word's compounded annually, it's going to be 1 time a year. And then we're going to do 1 times those 18 years before she gets to have this money. So again, you'll plug all that stuff into your calculator, and we get this beautiful answer of A equals to $3,379.93 rounded to the nearest penny because it's money. So we get about $33.80 if we were to round that just to be quick numbers. So she gets quite a bit of money for that $1,000 investment. So that's a pretty good deal for us, or for Jing Mei, because that's not me. Exponential decay is the exact same thing as exponential growth, except for it's decaying, therefore it is going downward, decay down. And so the formula, instead of being a plus R, is a minus R. So we'll do another example just like that, and then we'll be done for the day after you have your response question for us. So again, we'll use that formula. We're supposed to write an equation to deal with the situation that we have. So I'm going to give myself a little extra space here. Poor planning on my part, sorry. And let's go ahead and write ourselves that equation. So it's again, it is a y is equal to A will be the initial amount, which is 390,000, and then times 1 minus the 1.1% change to a decimal. So 2 times to the left, we got a 0.011. So 1 minus a 0.011, and then we're going to have that to the t power. Okay. Now, if you wanted to simplify that, you certainly could. That would turn into, just to double check, 1 minus a 0.011, 1 minus 0.011. Okay, just want to make sure. So in your calculator, you have a 0.989. Now, one thing you should notice is that decay formulas, they're going to have a number that is less than 1, and growth formulas are going to have a number that is greater than 1 in the parentheses, raised to the t power. So that's that simplified. So again, what we would end up doing here, folks, is we're going to type in the number 5 for t. So you're going to have 390,000 times a 0.989 to the 5th power. So 390,000 times a 0.989 to the 5th power. I just typed it in wrong, so I had fat finger syndrome. I'm going to type it in correctly this time. 390,000 times 0.989 to the 5th power. That time I got it correctly. And we get the answer of 369,016.7376. Now this is money again, so we're going to round to the nearest penny. So this is going to turn into a 7.4. And again, whoopsies, 7.4. Again, when we're dealing with this stuff, you should recognize that there is a pattern here, that the number is decreasing because it's decay. On the first problem, it was increasing because it is growth. Now, this is the last problem that you have to accomplish on the Google response stuff for me. And, uh-oh, spinning wheel of death, spinning wheel of death, spinning wheel of death. Spinning wheel of death has stopped. This is the next problem that you are going to need to do onto the Google form for me. All right, folks, thanks a lot for your help, and we will chat with you another time.